Okay, and here's our last example for the first part of 5-3. 5-3 is big, so I actually broke it up into 3 separate parts, but we might have to condense 2 of them. We'll see what happens. So we have this one. We're trying to solve for x. Right? We need to isolate cosine x to make that happen. I'm going to add 1. I'm going to divide by 2. I'll get this. I got to get rid of that squared, so I'm going to take a square root. If you have to put the square root, then you need to put a plus or minus symbol in front of it. Okay. The square root of 1 is just 1. The square root of 2 is the square root of 2. And with the plus or minus thing, well, let's see. When is cosine positive? Cosine is the x-coordinate. So cosine is positive here and here. When is cosine negative? Here and here. And we're getting all 4 again, okay? Hopefully you're recognizing 1 over the square root of 2, right? Adjacent over hypotenuse, 1 square root of 2. We're dealing with pi's over 4. This is 45 degrees. So we're going to have these 4 as our answers. Now the tricky part. The tricky part is deciding what is the most efficient way to write the general solution for this thing. Before, with tangent, we did this one and this one over and over and over because there's symmetry between these. Half a circle. Sure, you could do that here, but it wouldn't be the most efficient. You could write each one of these and just add 2 pi n each time to go around. That would work, but it's not the most efficient way, and you would lose a point. Okay? We need to recognize that to go from 1 pi over 4 to 3 pi over 4, and 3 pi over 4 to 5 pi over 4, and 5 to 7, and 7 to 9, thank you, and 9 to 11, 11 to 13, that there is symmetry between every single one of these. Each of these solutions is just separated by pi over 2, 2 pi over 4, right? From 1 to 3 is 2, from 3 to 5 is 2, so I'm actually only need to write one of these, pi over 4, but then I want to add 2 pi's over 4 over and over and over. 2 pi's over 4 over and over and over, positive or negative. I go the opposite direction. But 2 pi over 4 reduces, it's 90 degrees, pi over 2. There's 90 degrees between each one of these, 90 pi over 2 radians. So the final answer, pi over 4, the first one, plus half or 90 degrees over and over and over in either direction. Okay? So the idea is to draw your triangles where they go, see if you can spot symmetry, and then write the most efficient general solution possible. That's basically what we're doing here. We're still using 30, 60, 90s and 45, 45, 90s. We've been doing that for a long time. I told you guys memorizing those is going to be key. Okay, there's your stamp, page 481, 5 through 23 odd. Give me some honest effort on these stamps. From your guys' survey, a lot of you put 9s and 10s and 8s on how hard you're working on the stamps. I hope that's the case, okay? Because I'm not there to grade these. This is the effort points that people are asking for, but you still need to go through them and you need to treat them like they are being graded. If you can't do it, you need to ask. You need to fix it. You need to correct mistakes as you go through this. Okay, moving on. I will see you guys on the flip.